So the next topic would be thermal methods of surface hardening. So in that surface hardening technique, how a thermal method is involving, there are two types of thermal methods like flame hardening and induction hardening. So the thermal methods is applied because one of the following reason, only a small segment or section or area of the part needs to be heat treated. Then we can go with this methodology. Some of the examples of this kind of an application like the end of the valve stems and push rods and bearing surfaces of the cam and levers. So better dimensional accuracy of the heat treated part, overall cost savings by using inexpensive steels to have the wear properties of alloyed steels. So these are all the methodologies that we are going to improve the flame hardening method. So in that flame hardening, we know that this is a typical diagram for flame hardening technology. In that we are applying a gas, natural gas, that means compressed natural gas or liquefied petroleum gas. Both can be used. So here we are using LPG. So in that LPG, we may able to create a flame like this. So the starch will create a flame. So once the flame can be generated, so it can be passed over the material. So this is our material. So it can be passed over the material on particular time and the particular temperature reaches. So after reaches the particular temperature and particular time, then the quenching process can be taken place. Once the material is heated and the sudden quenching can be taken place, then automatically the surface hardness can be improved. So if we want to improve a particular area of this entire material, so we don't want to adopt any other methodology to improve the hardness. We can go with this kind of a flame hardening to improve that particular area's hardness. So by using this kind of a flame induction methodology. So this is one of the best example for flame hardening method. The next topic is introduction hardening. Induction hardening is nothing but the in between the shaft, over the shaft we are having, there are two types of induction system. Induction series will be there. So in this induction series, we'll having a series of winding. So in that series of winding, we may apply the electrical energy. So if we are supplying the electrical energy to this series of winding, then what happens? So automatically in between this series of winding, the heat flux will be produced. If we cut with the help of this material, then heat flux will be generated. So based on this heat flux, the temperature of this component can be increased over the surface. So on that time, we can applying the punching medium with the help of an inlet. So if we are applying the punching medium, then we can reduce the temperature too. So with this help of induction hardening methodology, also we can improve a particular area's hardness. So this is the best example for flame hardening and induction hardening for improving a particular area of hardness. If you are having, for an example, if I am having a, bar of length nearly 10 meters, so if I am having a 10-meter steel bar, but if the contact area of the steel bar is only 200 mm, so if the 200 mm of the contact area to be hardened. So on that case, what I'm going to do is I can able to implement either flame hardening or induction hardening, because the entire 10-meter length of the bar is not to be hardened, because that is not sufficient. That is not enough for it leads to the material wastage. So in avoiding to the materials wastage, so and also the cost reduction of the cost purpose, we are going to implement the case hardened methodologies. So in that case hardening methodologies, we can able to implement thermal methods like flame hardening and induction hardening based on our requirements. Thank you.